Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 9B assignment. Okay, start here with number 1. Which of these graphs show periodic behavior? So remember, periodic behavior, you're looking for something that repeats horizontally. So if we look at this part from here to here, if you pick this blue piece up and slide it over, guess what? It ends up being this piece right here. It's the exact same. All right, and if you pick that up and slide it over again, it ends up being this piece right here. So this one is periodic. Okay, and then this one here, it's the same idea. This pattern here, basically just look to where it starts to do the same thing over again. It goes to right about there, and if you pick that whole thing up and move it over, then guess what? We get the exact same thing. Oops. You get the idea there. And then we do it one more time. Pick it up, slide it over, and there's our next one. So this one, C here, is also periodic. Okay. E here, if we take this thing here and trace this until it starts repeating, it's going to start repeating right there, right? Because we pick that thing up and slide it over, it makes this exact same red one right here. So that again is continuing to repeat, so also periodic. Okay, and then G here, now you can see that this makes a pattern and it does repeat itself, but it's not repeating itself horizontally, right? If it was repeating itself horizontally, this right here would then have to start back down here, and then it would have to come up, well, you get the idea, I hope. It's going to have to come up like this for it to be periodic. It's going to have to do the same thing over and over, but it doesn't. It's got this thing here instead. So that means that this is not periodic. Oops. Okay. All right. Number 3, Paul spun the wheel of his bicycle. The following tabled values show the height above ground of a point on the wheel at various times. Okay. Plot the graph of height against time. So I took the liberty of using the graph out of the back of the book just because it's going to end up looking so much nicer than mine. But really the big thing here is that you just want to, this is going to be your X, and this is going to be your Y. And this is a continuation of the X and the Y here. So we want to go from 0 up to 4. So that's why we go from 0 to 4 here. And then we want to find the lowest and the highest. So it looks like 0 is the lowest. And what do we got? 64 is the highest. So it's got to go from 0 all the way up to 64 on our Y scale. And then literally just plotting points. 0, 0. 0.2 is at 6. 0.4 is at 23. So forth and so on. Graph all those points. And we have plotted our graph of height against time. Is it reasonable to fit a curve to this data, or should we leave it as discrete points? So in other words, does it make sense that we should be able to connect these dots here together with this graph? Like really, if you were to go in between that, like if we were to put in 0.5, that point is going to be somewhere in between, pretty much right on that line. So yes, it would be reasonable. It is reasonable. Okay. Reasonable. How about let's just do reasonable. Discrete points would mean like it wouldn't necessarily connect right between, like this 0.5 might not exist, or it might be way down here or way up there. So then that would be a spot where you would leave it as discrete points. Okay. Is this data periodic? It sure looks like it, right? Because we go from here up to here and back down here, and now we're going to repeat, right? It's going to do the same thing over again, and then we can keep doing it over and over and over. So yes, this is periodic. So if it is, estimate, doesn't mean calculate, estimate the equation of the principal axis. So that's right in the middle. Goes from 0 to 64. I know we're supposed to estimate. It's kind of right in the middle there. That's it's kind of an interesting thing to estimate, because it's a pretty simple calculation. You take the top number 64 minus the bottom number and divide by 2, right? And that will give you the principal axis. That gives us 32. The equation of the principal axis. So here's the big key, equation of the principal axis. So that's this right here up at 32. That's the principal axis, PA, right? And then that, since that cuts through the y-axis, I like to call that y equals 32. And that should be just fine for what we need. Okay. Part 2, the maximum value. Well, we know the maximum is right there, 64. Okay. Minimum value is 0, right? The period, how long it takes to repeat. So look, it starts here at 0 and it comes back down at 2. So it's every 2 seconds. 2 seconds. And then figure out what the amplitude is. So from 32 up to the top is going to be, so if we do 64 minus 32, guess what? We actually get 32 again for the amplitude. Okay? Okay. And really that's all we have for the 9B assignment. So if you have any further questions, please feel free to ask. Thanks.